that discusses general workflow concepts. Today we're going to talk about more specific advanced topics. Now, the topics and models that I'm going to be talking about today are the same topics and models that I discussed at Autodesk University last December. And so if any of you were attending that one, this will all look somewhat familiar to you. And then I'm going to be giving another presentation at Autodesk University this year. So for those of you who want to come out to Las Vegas and see a bigger presentation on RISA and Revit, feel free to join us. Anyway, today we're going to be talking about the RISA-Revit 2015 link. And so that integrates Revit or Revit Structure 2015 with RISA 3D version 12 and RISA Floor version 8. Now, even though we're going to be talking about the 2015 link today, everything that I discuss is also relevant for our 2014 link, which is still available up on our website. Now, the important thing to keep in mind is that's the 2014 V2 link, which contains a lot of enhancements over the original 2014 link, which was released over a year ago. But all these ideas are still the same. The Structure 2015 link and the Revit 2014 V2 link behave identically. So let's talk for a moment about the improvements that came about in the 2014 V2 link, because of course those are also essentially improvements in 2015 over what we had a year ago. We have been hard at work over the last year putting a lot of new features and bug fixes into the link to make it better than ever. And so you'll see here 14 significant new features, and we've been taking care of a lot of minor things as well. And so I'm going to give you just an overview in a slideshow format here of some of the big new features that we've put into the program, and then we're going to discuss the advanced topics and go into individual models and see how these features interact with the link and see how to use the link to its fullest potential. So the first one I'd like to point out is the wood wall transfer. In all prior versions of the link, we've been able to send wall geometry information back and forth and just general wall material information, so we know what material type is being used. Now, for masonry and concrete, that's sufficient, but for wood walls, we have other information that's also relevant, such as the type of sheathing and the nailing that's going to be used in the program. And so what we've done is we've created special parameters that are accessible through Revit now, so that after you solve a wood model in RISA and bring that model into Revit, it brings over the sheathing grade, the sheathing, and the nailing as well. And you can use this information to actually build a wall schedule or to tag your walls in Revit so that you can send that information right along to your construction drawings. Next, we've now improved the round tripping of curved beams. Now, this is for RISA 3D only. Bear in mind that RISA Floor doesn't currently support curved beams. But in RISA 3D now, if you have a curved beam that's present in Revit and you bring it into RISA 3D, we will automatically break that beam up into a series of segments. And then if you change anything, we'll just bring that back into Revit accordingly. And so you can actually round trip back and forth now without having it break up your Revit curved beam into a bunch of straight line elements like are used in RISA for analysis. So keep in mind that that's now an option. We also have now added support for edit profile wall openings. So for those of you who don't know, if you go back a couple of years ago, you only used to be able to bring over wall opening elements that represented wall openings. Now last year we added window and door opening types, and now we've sort of rounded it out so that you can cover all different openings by bringing in the edit profile wall openings for windows. So this means that in Revit you can edit the profile of a wall and draw these lines in here, almost forming a donut type shape here, and we're going to be able to bring that back and forth, and I'll show that to you live today. We've also added dummy members for missing shapes. Now, this has been present for a long time when going from Revit to RISA. That is to say that if there's a shape present in the Revit model that we don't have available in the RISA model, we'll just create a dummy shape. Usually it's a rectangular 1-inch by 1-inch member. So that way the member itself comes across and we just rely on you to actually fill in the information on what that shape type is. We've now done it in the opposite direction as well. And so when you're coming from RISA into Revit, if we can't find the corresponding shape in Revit to your RISA shape, previously we wouldn't bring that over at all. Now we'll actually bring it over, and we color code it as purple in your Revit model so that you know to go in and assign the correct shape properties to that. Another big new feature is we have now added full support for partitioning your Revit model. What does this mean? Well, let's say that you've got a giant Revit model, and that Revit model consists of multiple independent structures that you want to handle in separate RISA models. Well, you can take that Revit model, and using the Export Selected Items Only option, you can export out from Revit into multiple different RISA models. And as long as these RISA models are exclusive, that is to say that if any given beam is only present in one RISA model, that it doesn't overlap between multiple ones, then after working in these separate RISA models, you can now bring all those RISA models back together into that one parent Revit model again without having it affect any of the elements that were part of the other ones. So this is another useful workflow that I'll be demonstrating live today. Another thing that we've introduced is better support for Worksets, and I'm going to show you that as well. And with this, we now check during import to see if any of the Worksets that your elements are on are not editable in some way. And what that does is that allows you to halt the import process without going through the whole long import, so that you can then go into your Worksets and obtain the rights to be able to edit those. Otherwise, you have to sit through the entire import process only to find out that it wasn't allowed in the first place and hit cancel and undo the entire import. So this will save you a lot of hassle with that. A huge new feature is that we've now allowed you to bring the RISA floor, bring the Revit Analytical model into RISA floor. So previously, RISA floor always linked to the Revit physical model. Now you get an option whether you want to bring the Revit Analytical model or the physical model over, and so this makes it a lot easier to not have to set certain things like reference levels, and you're going to see that very clearly as well in the presentation today. We've added support for analytical links, and so those analytical links in Revit will now come into RISA 3D as rigid links. And similarly, if you draw a rigid link in RISA 3D, it'll now come over into Revit as analytical links. So this helps a lot with the column beam offsets and the such. We've introduced a member label property in Revit. So now all of your analytical beams in Revit have this RISA beam label, or your analytical columns have a RISA column label property. And that tells you what the member label was in RISA 3D. This is really handy because when you're in Revit, you can pick out a member and find out what it was named in the RISA model and easily find that same one in the RISA model. For big models where it's hard to keep track of where all your beams and columns are, that's a huge plus. We've also added joint and member label persistence. And so what this essentially means is that when I start off in Revit and come into RISA, on that initial import to RISA, we make a name for everything. Now, the default prefix for everything is this REV underscore, so that tells you that came from Revit. But basically, we just create a sort of randomized name for all of the members and joints. Now, you're free in RISA 3D and in RISA Floor to rename these joints and these beams and everything else to whatever you want. So if you have a more easy to understand naming convention for your members and for your joints that you like to use, say everything on floor 1 has an F1 prefix, you can go in and set that. Now, one of the setbacks was that in previous versions of the RISA-Revit link, when you did the round trip, it would just stop over those names and set it back to what it wanted to. But now it actually keeps a memory for those names. And so when you start naming things in RISA, you don't have to worry about getting all that wiped out when you do your round trips to Revit. That's a really handy way to keep things consistent through multiple round trips. Another thing we've added is the support to disable analytical wall openings. And so you can essentially pick and choose which openings in a wall you want to come back and forth into RISA. And when you disable these, we'll just ignore them entirely. So not only will we not bring this disabled opening over into RISA, but when we come back from RISA, we won't delete this physical opening in the model because its analytical has been disabled. Another huge feature, you can now pick and choose which levels you want to transfer into RISA Floor. So we recognize that in a lot of cases, you've got tons of levels in your model. A lot of times they're architect created or used to create specific work planes or the such, but these levels don't represent actual floors in the building. And so you want to be able to tell the program which levels are actually floors in the building and which ones aren't, so that you don't end up bringing over a whole bunch of dummy levels into RISA Floor. We've now added a property to the levels themselves, which is called RISA Structural Floor. And if that box is unchecked, then that entire level is ignored when importing into RISA floors. This is very handy. And then lastly, we've got this support for sloped walls. And so this is just sort of finishing off our final support of sloped roofs back and forth from RISA to Revit, whereby in RISA floor you can actually create sloped walls, and we can now bring those back and forth to Revit without flattening them out as we used to. So that makes sloped roofs a lot easier to transfer back and forth. Oh, and column splices as well. You can also bring your column splice information back and forth. We control all of that in Revit through the top connection, and we control it in RISA floor through the splice connection, which is the base of the column. So you just have to keep that clear. This is more important just for keeping your column splices consistent through multiple round trips. So with that being said, this is the overview in slideshow form, but I think everybody wants to see things done sort of live in person so they can see how all this is handled. So what I'm going to do now is I'm going to open up an existing Revit model that I have. And I'm opening this up in Revit Structure 2015 using the RISA-Revit 2015 link. And if you don't have that already, that's a free download from our website. And what you're going to see in this model that I've got here is I've got a relatively basic multi-story structure, but this is the sort of structure that's caused a lot of issues in the past, certainly with going into RISA floor. Now, RISA 3D can handle just about any geometry, but because RISA floor is a building-specific design program, it needs to have geometry fall within certain constraints. And one of those constraints is that you must have clearly defined floor levels for everything. Well, in this case, this structure, at face value anyway, looks like it does have clearly defined floor levels. But one of the issues that we're going to run into is if I export this out, I'm just going to go to Export to RISA floor, and we will create an Exchange file for this, and hit OK on that. We're going to get a warning right out of the gate, and this warning says export failed for the column, no match found for top level parameter. We're going to have to go back and figure out what that's about. I'm going to hit ignore for now, and then we get the RISA-Revit report telling us the same thing. Now when RISA floor opens up, what I'm going to get out of this model actually is just a great big mess. So if I come in here, I've got these multiple floors where I'm missing beams, I'm missing columns. If I go into a full model view, this is the extent of what we've got brought into RISA floor. And that's coming out of this Revit model, which has a whole lot more information. And so for those of you who haven't been very meticulous about how your levels and reference planes are in the past, you've probably run into this issue a fair amount. Well, what we're dealing with here is problems related to the physical model. Because by default, we take a look at the physical model, or at least a lot of physical model properties, when going back and forth from RISA floor to Revit, whereas in RISA 3D, we're focusing more on the analytical model. And so if I take a look at the physical model here, one thing I find, let's just take a look at the elevations in this model. I'm going to snap into a side elevation, and what you see here is I've got a whole bunch of different levels. So I've got grade and top of footing defined in here. I have this second floor, and then I've also got a second floor top of steel as well. I've got a third floor, finished floor elevation, and then the third floor top of steel as well. Roof low point, roof high point, and parapet. So a ton of different levels used to define this whole model, but we really don't need this many floors. So inherently coming into RISA floor, we'd just be creating a big mess. So what I've done in this case is I've actually assigned which levels are supposed to come over in the RISA floor so that we don't have a ton of these different levels. So if I come in here and click on this grade level, for example, on the left we can see that there's this RISA structural floor checkbox, and that's unchecked. That means that the RISA-Revit link should ignore this level when going back and forth. For the top of footing, we are considering that because that defines the base of the columns here. Now if I take a look at this column, for example, we can see that this taller column is using a top level of roof high point. But if I come up to roof high point here, I can see that that is not defined as a RISA structural floor. Why is that? Well, in RISA floor, when we're dealing with sloped roofs, we always want to create the roof at the low point because you can only slope upwards in RISA floor. So the roof low point is a relevant level. The roof high point is not, so we didn't bother bringing that over. Now similarly, all of my beams here are defined as part of a top of steel level, whereas the floor system itself is defined on the floor, the finished floor elevation level. So I just have to pick one of these two that I want to bring over back and forth to RISA floor, and in this case, I've chosen the finished floor elevation levels that I'm bringing over. So if I come into my floor spreadsheet, you can see there's really only 3 relevant levels, aside from the base of the column, which doesn't get represented as an elevated floor here, and that is the second floor FFE, third floor FFE, and roof low point. Everything else is just extra, so I've shut all those off. But I've got a problem with these columns in that they're referencing a floor level that's not actually present because the RISA-Revit Link is ignoring it. So that's why those taller columns don't get brought over. Now, in addition to this, I've got other issues, such as the fact that these roof beams, if I come in and take a look, the roof joists that are supposed to be running along here are not showing up in the RISA model. Why is that? Well, if I click on one of those roof joists, what we're going to see is that it's defined with its reference level as the second floor with a 30-some foot offset. So in general, that's just bad modeling, but we've seen this occur in so many different Revit models that have come through. We realize that even though it's not the ideal modeling, the link needs to be more flexible to allow people to sort of make these mistakes and not completely crush your design going back and forth. So what we have always said from day one is that people need to focus on the analytical model. And if I come in and take a look at the analytical model for this, what you'll see is that everything is all at the correct levels that it needs to be. So in this case, for example, if I come down to these beams, we can see that these beams right here at the third floor are at reference level FFE. These ones here are at reference level second floor top of steel. And so they're offset down just a little bit from the floor level itself. But with this beam, if I take a look at its analytical beam, what we'll also find out is that it has been set to have an analytical projection up to the second floor FFE. In other words, the beam itself exists at top of steel, and that allows us to move all of these beams up and down relatively easily if I have a thicker or thinner slab. But the analytical beam is linked to the actual floor elevation directly above it. And so we see that in the 3D analytical model. Now, another important thing to consider when we came back and forth from RISA floor is that I've got these beams right here that are part of a sloped low roof. And those are these beams right here in the RISA floor model. And if I come into the Revit model and take a look at those same beams, what you're going to see is there's a gradual slope right here in this area on the side of the building. Well, for those of you who don't already know, RISA floor currently only supports the top level of a structure to be sloped. And so in the past, what would happen, and in fact what's happened right here, is the program has flattened those beams out because it doesn't allow this floor level to be sloped at all. Well, if I then take this RISA floor model and bring it back into Revit, it's going to flatten these beams as well. It'll flatten the physical beams, and that'll make all of my drawings incorrect because those are supposed to be sloped beams, and we need them to exist as sloped beams in Revit. Well, the workaround here is that I've actually taken the analytical lines for those beams, and I've assigned them to be flat. On a relatively low slope like this, I don't mind if these beams get designed as though they're flat. It's not like they're going to pick up a bunch of extra axial load. But this is now going to allow me to have this inherent discrepancy between a sloped physical beam but a flat analytical beam. Now, at the end of the day, the most important thing here is we want the RISA floor model to have everything based off of this analytical model, which we've done all the cleanup for. So if I go back to export to RISA, this time I'm going to check this extra box, and this is a newer option in the program here, which is link to Revit analytical model, and that's as opposed to physical. And so when I hit that and hit OK, now it's going to export the analytical model to RISA floor instead of the physical model. And what you'll see now is we've actually got everything now brought over because things were analytically modeled correct, even if they weren't physically modeled correct. And so then at this point, I can now solve the RISA floor model. It looks like I've got an unsupported member in this case, so I'd have to go back and clean that up. But essentially, we've got everything correctly brought over here, and we could do round tripping without worrying about damaging our Revit model. So that's a very important model to take a look at. Next, I'm going to open up another model where we can troubleshoot some other issues relating to analytical models, specifically analytical adjustments. And so in this model that I'm opening in Revit right here, what I've got is a really basic concrete structure. And so here I've got these concrete beams, columns, and a wall set up. And we can see how this all frames together. Now, one of the things that's common with concrete construction is that my spandrel beams here are aligned with the face of the column on the outside and with the face of the wall and the such. And so physically, this looks exactly the way that we would construct a building like this. But of course, analytically, that does pose a problem because the analytical model is based off of center lines. And so looking in here, I can see I've got center lines on the beams and columns. Things don't quite line up. This becomes especially clear when I take a look at just the analytical model by itself in Revit, and I can see here things are not connecting to each other. Now remember that when we export to RISA, if something doesn't connect analytically, it's not going to connect in the RISA model, so things will not be attached to each other. If I export this model out to RISA 3D, I'm just going to set up a exchange file for this one as well. What we'll find is that things don't connect with each other. And this is one of the most common technical support things that we deal with in the RISA-Revit link, is that people export from Revit, taking a look just at their physical model, and they say, hey, I've exported my model out to RISA 3D, and I get all these instabilities. Nothing attaches to anything else. It must be a bug with the link. Well, it's not a bug with the link. We're taking a look at that analytical model, and if you haven't spent the extra time to clean up your analytical model in Revit, then it's the old garbage in, garbage out concept. So you really need to make sure that this is all looking correct. Now, a model like this in the past would have been more difficult to deal with, and one of the reasons behind that is that these columns have their analytical lines set at the center of the column. It's hard for me to explain to the program that that analytical line needs to be offset to some location in the column. I can easily offset the analytical line to the face of the column. What we're dealing with here is a beam where the analytical is not at the face of the beam itself, and so if I move this analytical column line out to either column face, it's still not going to hit that column beam intersection. Now, another option I have here is to go in and do an analytical adjustment on the model. But when I do this analytical adjustment, grabbing the top of the column is easy. With the bottom of the column, though, it becomes very difficult for me to get this column plumb again. And so trying to work with these analytical adjustments, not only in the 3D view, but in the 2D views as well, can be very challenging to offset this column's analytical line entirely from its physical column. Well, instead, what we're going to do is we're going to use analytical links to accomplish this. So I'm going to come back over to the analytical model, and I'm going to click on the analytical column. And in Revit, we have this checkbox. It's a property of the analytical column called analytical links. And if I check that box, what it does is that senses any beams that come very close to the column but don't quite connect to its center line, and it juts out a little rigid link to pick up that beam. Now, in this case, I've got these rigid link sort of boxed out with these beams in the corner. That's going to create a very rigid condition in that corner, maybe a little too rigid for what I'd like for analysis. And so I'm actually going to come in and do an analytical adjustment where I then pull these beams back to the analytical lines. And what we're going to get now is this beam framing in with a rigid link to the edge of the column. That's appropriately going to place a bending moment into the column due to the eccentricity of the beam itself. Because, of course, any vertical load on this beam is going to put a certain amount of bending in this direction just due to that coming down not centered on the column. Now, similarly, on this column here in the middle, I can enable the analytical links. If I don't want to do the automatic analytical links, which we have here, I can also manually draw them in. So if I come in and go into the analytical adjust mode, there's an analytical link option. And if I click that, I can just draw that between any two nodes. And so now I've drawn this little rigid link in here that connects those two members. At this point, I can now export that out to RISA 3D. And with that update, we can take a look at the RISA 3D model, and we're going to see now that these columns are, in fact, connected using these rigid links on here. So that correctly worked. And at this point, I should be able to solve this model without getting instabilities. So I'm going to come into this model here, and I'm going to put some boundary conditions in. And I'm going to solve this model just for gravity only. We finish the solution, no instability warning, so everything worked out all right. As I always recommend, I'm going to take a look at the deflected shape to make sure that everything looks okay. And yep, we can see everything is looking fine, so the model's behaving the way we would like. But when I flip over to that deflected shape, I also see some weird issues going on with the mesh of the wall. And one of those issues is that I've got this very tight mesh around these tiny little openings on here. And so, coming into the Revit model, if I take a look at those tiny openings that we've got in here, what I'm going to find is that these are very small. In fact, these openings are only about 1 foot by 1 foot, and these openings were put into the model to represent piping penetration. Now, you may have this a lot in your Revit models because, of course, you're going to have to go in and the MEP aspects of the model are going to have to run pipes through walls. And for the most part, you're not going to care whether there's a little 6-inch opening, say, cut through the wall to have these pipes in there. You don't want that as part of your structural model. That creates a whole lot of excess complexity to the way this is done. I mean, even the region design here, we're now going to get separate rebar design in between each one of those openings, when in reality, these are structurally insignificant openings. Well, what I can do to get around that is I can come into my analytical model, and if I click on the wall here, I can do the analytical adjustment, and I can choose this openings option and uncheck those openings. And what that does is that eliminates the openings from the analytical model, although they are still present for the physical model. So that's kind of handy to have those in there for the physical model. Now you won't have clash detection issues with your MEP. Now your drawings will come out correct, but the analysis won't include these insignificant little openings. Now I am going to add another wall opening in here just to show you that edit profile option that I mentioned before. And so that allows me to click on any wall and go into the edit profile mode, and now I can just draw in an opening. And that opening will show up by default as an analytical opening, but I could actually remove that from my analysis if I wanted to. Now I don't actually want to do that, so that's not going to be an issue. Now one other thing to point out, if I come into my Revit model here, my RISA model, is that the wall is extending all the way out to the edge of the wall, but the beam is framing in right here. This is also creating sort of a weird mesh condition right in the corner of that wall, and that's not as accurate as I'd like it to be. So by default, when I'm working within Revit, I've got the wall extending analytically all the way out to the edges of the wall. But if I come into that analytical adjust in Revit once again, let me just snap back to my analytical model, I can choose this analytical adjust option and do a wall adjustment, and I can pull those wall edges back to the beams. So that way this also comes over in more of a clean fashion. And that's less likely to give me meshing errors when I'm coming into RISA 3D, and it means that the model should just, in general, solve better. So now if I export this model back out to RISA 3D, we will now correctly get that set. And so now the wall goes exactly where it needs to. The minor openings aren't coming through. The big opening is, and these columns are all set. So now at this point, I can actually come back in. I didn't do a round trip, so because I did 2 multiple exports to RISA without round tripping, I lost those boundary conditions and the load combinations. Probably would have been smarter for me to do a round trip on that one instead. And so looks like I'm running into a little bit of an issue here, but that's all fine. Now, the next thing I want to do is I want to select the beams and give the beams their own name. So if I take a look at what these beams are named right now, and I take a look at the RISA member label, you can see it's Rev M5, Rev M7, so on and so forth. Maybe I want to relabel these so that I can know better what is a beam versus what's a column. Well, in RISA 3D, if I have those members selected, I can right-click, and there is a Relabel Selected option. And so I'm going to say relabel the selected members, and I want it to relabel them with a B prefix for beam, and hit OK. And now we have B1, 2, 3, and 4 all set in the model here. Now I can save this model and export it back out to Revit. And so we'll just go right back over. It looks like we're overwriting the existing Exchange file, but in reality we're merging the changes into it. And now I can import back from Revit into or back from RISA 3D into Revit, and we're going to bring that information and any changes over. Now in here, the only modification I've got is just on the wall, and that was just related to us updating the wall with more sophisticated materials in RISA as opposed to Revit. But one handy thing now is when I'm in Revit, if I click on one of those analytical beams, I can see the RISA beam label. So that's set to B1. So we now actually have that information stored in the Revit model so that later on, if I'm working in RISA 3D and I say, wow, I'm getting a member failure here on B4, I can go into my Revit model and actually see what B4 is. So another handy tool that's available in these newer versions. I'm now going to close out of this model, and we're going to take a look at a model that involves having custom shapes. And so for that, I'm actually going to open this model up in RISA 3D. And what you're going to see here is that I've got these shapes defined in my RISA 3D model, which is a W16 by 36M. So that's for modified. And if I take a look at what that W36 or 16 by 36M is in the RISA shapes database, I see that that's coming out of RISA section. And so I actually have the RISA section model here. And in there, I can see that I've defined this custom shape in here as a wide flange with some extra plate on the web. And so that's just to differentiate it from something else. This is what a W16 by 36M looks like. Now, in addition to that, what I've actually done is I have created a Revit custom library that I called Match Shape. And in that Revit custom library, I've got a shape type defined as a W16 by 36 with all of its section properties. Now, don't be mistaken in thinking that we're bringing all the section properties back and forth. It's actually a lot more complex than you would think to be able to do that. But if I create a custom shape in RISA and then also create that in Revit, by creating those two, we can now map them together with each other. Now, for my Revit custom shape, note that I stored it in a steel folder that is under a structural framing folder, and that's part of my custom library. That folder structure is important because this folder structure mimics the Revit family folder structure. Now, if I take this model right here and bring it into Revit, what I'm going to encounter is an error. So I'm going to come into Revit right now and just create a new project real quick. And we'll come in and save this project. And I'm going to put this right into the same folder where we've been working before. This will be my Revit Model 5. And then I'm going to go to the add-ins within that Revit model and import from RISA. And I, of course, in RISA have to export that exchange file. So I'm going to say export exchange file. Model 5 will be the exchange file name. And when I bring this into Revit and hit OK, what we're going to see is it's going to bring the entire model in, but I'm going to run into an issue in that I don't have that shape. So I get this warning right here. W16 by 36M hot rolled steel framing was not found in the current project or the Revit structure default libraries. And so that means that this 16 by 36M, Revit is not aware of what that shape is. And so what it's done is it's actually created a dummy shape for me and brought that in and color-coded these purple, so that now I know these are the problem shapes. So one thing I could do at this point is I could go in and load that 16 by 36M into my Revit project and then manually apply it to these beams. But instead, I'm actually going to undo what I just did, and I'm going to re-import. And what I'm going to do when I re-import here is I'm going to go into the Advanced tab. Under the Advanced tab, I have Shape Library options. And so we can see right now when we do the import and export, we're only looking at Revit's default Imperial library. But I'm also going to specify a custom library as well. And that custom library, if I point to it, is going to be right here, my custom library folder. And so now what will happen is when we import, the RISA-Revit link will look at both the Imperial library and the custom library to see if anything matches. So when I hit OK on that, now we're not getting a warning when we import. Instead, it's able to correctly find that shape and then load it into the project. And so we can see that that's actually come in. And because it had the same name, W16 by 36M, as it did in the RISA model, I didn't even have to use the mapping file. So that mapping file that we use that I discuss in the other webinar is only necessary when the shape name is different between RISA and Revit. And if I zoom in here, we can actually see that my Revit beam is defined as that wide flange with that horizontal bar in there. So this makes it easy for you to take any of your custom families that you've got, and as long as they adhere to that specific folder structure that Revit has, then you can just have the link pick those up as it goes along. You don't have to individually load those shapes in, so that's quite handy. The next thing I'd like to show you is splitting a model apart between multiple, splitting one Revit model apart into multiple RISA models. And so for that, I'm going to open up another existing model that I've got here. And this is a model of two building type structures with a bridge in between them. So what we've got is these building type structures, which presumably are going to be made out of composite steel. And so those are ideal for sending in a RISA floor, where we can get floor vibration checks, composite steel design and the such. But then we've also got this bridge structure, and RISA floor is not going to be able to handle that. RISA floor can't do things like curved archways and trusses and the such. That's a more complex thing that RISA 3D would have to take a look at. At the same time, though, if I bring this entire structure into RISA 3D, I'm going to miss out on things like composite design and floor vibration checks, which are important for this structure. So what I really got to do is I've got to be able to partition this structure out and be able to do separate designs. So one option I have for this is I can actually just highlight these portions of the structure here. And let me just grab that one and that one. And so now with just these beams highlighted right here, I can now go to export, and I can export that out to RISA floor using this export selected items only option. And so this allows me to export only the items that we're looking at into RISA floor. And so I could come in here and say export this, and I want to use two different exchange files. So for this, I'm going to use the Model 6 FL for floor, and this is going to be my floor exchange file. And so when I hit OK, that should kick us out into RISA floor. And it's just about done creating that model. And when we import it, we're going to have everything but the bridge present in this RISA floor model. And so we can see here, there's the entire structure without the bridge because we only exported that. Now, concurrently with what's going on with that RISA floor model, let's say I've got one engineer who's already working away on that, I can have another engineer now grab just the bridge by itself, and we can export that bridge using the export selected items only into RISA 3D. So now I'm going to create this as a Model 6 3D exchange file, totally separate from the RISA floor model that I'm already working with. And so then that is going to export out into RISA 3D. And then with the RISA 3D model then, I can work separately on this portion of this bridge structure. And when I'm done working on both of these, I can bring them both back together and import them both back into my Revit model. And as long as I make sure to coordinate changes, that being, let's say that I was to make this truss 2 feet higher here by coming into RISA 3D and just moving that top chord up by 2 feet, I would need to make sure to coordinate with the RISA floor user to make sure that he also raises his floor level by 2 feet. Otherwise, when we bring these both back into Revit, we're going to have a discrepancy, and one of the two of them is going to trump. So the point I'm trying to make here is that you can now do some sort of simultaneous workflow by using this export selected items only and carefully managing things, but you need to make sure that everybody coordinates with everyone else when you're making physical changes to the model, because those physical changes have to keep the entire model intact. Now, an alternative approach to this model would be to actually use this model to create a RISA 3D and RISA floor combined model. What I'm going to do for that is I'm going to highlight just the bridge in my Revit model, and I'm going to select just those horizontal framing members, which are currently defined as a joist type horizontal framing member. And you'll see that there's a special code in here in Revit to define the structural usage. And whether you call something a girder, a joist, an other, or a purlin, it's all the same as far as RISA is concerned for analysis. But horizontal bracing is a little bit different. If I say that all of these members are horizontal bracing, for horizontal bracing, we still get the same code checks for bending and axial and everything else as we would get for beams, but that's a code that tells RISA floor to ignore that member. Now I can actually export this entire model. So let me just export this without a suffix at all into RISA Floor without the export selected items only option chosen on here. And I'll hit OK. And what that's going to do is create an entirely new RISA Floor model separate from the ones that we worked with before. And in this separate RISA Floor model, it's going to be smart enough to filter out those horizontal bracing members I have. So in this case, I can solve the model. And so it's just going to run through and do an analysis. Now you'll note that while I'm in RISA Floor right now, I don't actually have that bridge present. But I did get a design, and then now using the Director tool and going into RISA 3D, I can now come in and see that that bridge structure has come over. So it's present on the RISA 3D model side. And so at this point, I can now actually apply my loads. And while the point loads from the ends of that bridge are not going to show up in the RISA Floor analysis, as long as I make these girders which pick up the bridge lateral members, they will show up in RISA 3D because, of course, we filter out the gravity and lateral between floor and 3D so that only the lateral members show up. So on the RISA 3D side of this RISA Floor model, I can keep everything together and run this analysis. Now, why is it that these members are set to lateral and are showing up in 3D, and the other ones are set to gravity and aren't? Well, I just went ahead of time in my Revit model and defined which members were lateral and gravity. And you can do that in Revit by taking a look at the analytical properties of each element. So this column right here is defined with Analyze As, and you have lateral or gravity as options. So I have all my lateral frames and my gravity frames differentiated separately when I came into RISA Floor. And so you can see by using that horizontal bracing trick, you can bring all sorts of members, at least beam-type members, from Revit into RISA Floor and get around some of the geometry restrictions in RISA Floor that wouldn't allow things like curved bridges, and just get your analysis all in one model. So another handy tool to have available. Now, for those of you who deal with Worksets at all, you may have sort of dealt with a headache relating to those, and that being that sometimes you don't have all of your Worksets checked out or editable at any given time. And what I've got right here is this exact same model, but in this case, this model was copied down from a central model. And so if I come into the Collaborate in the Worksets tab, what we're going to see is that for the building workset and the bridge workset, Debbie has borrowed those worksets, and so she currently has them. She's the owner, and these worksets are not editable. And so if I export this model out, it's actually not a problem because I can export anything without worrying about editability. It's on the import side that we're going to run into trouble. And so this is just exporting into RISA 3D right now for the sake of speed. And so here's our entire model in RISA 3D. If I attempt to change this model and bring it back into Revit, I'm going to hit some issues, though. Let's say that I grab that entire top floor, sort of similar to what we did before, and I move that up by 3 feet and save this model and export it back out to Revit. Because I don't own the building workset and the bridge workset, I should run into issues. And prior to this, we would have to just sit through all of those issues processing. But now, when I try to bring this back in, the link right out of the gate lets me know that some worksets are not editable. Import process may be prohibited. So this is just your first step of a reminder that says, hey, we saw some worksets aren't editable. We don't know whether there's members that are affected or not, but you might want to go back and take a look at that. So you can cancel it right now. But let's say that I'm confident of saying, oh, yeah, no, I'm sure I've got these. Okay. When I hit OK, now the link is actually going to get a little bit more sophisticated, and it's going to run through here. And during this import process, it's going to identify where these problem worksets are. So that's going to allow me to get back and edit them. So you can see it's actually coming in and trying to create those beams and columns and braces, but it's quickly going to run across some problems, and so it should give me a warning relating to that. Now, if everything was fine, then what we would see is that this floor level would move up by 3 feet, just like we edited in RISA 3D here, and then we should see that the beams would be color-coded black as opposed to yellow since they weren't modified. But instead, we get our error report right here that says workset, the building, the levels, and the bridge are all not editable. And so that when I hit OK now, Now this means that essentially Revit's going to come in, it's going to yell at me because of all this and tell me that Debbie has these issues, that Debbie has ownership of these elements, and so then I have to actually cancel that import. And so what we've got here, you'll have to give it just a minute. Believe it or not, Revit actually has to go in and update each one of these members one at a time in order to address these sort of issues, and it's part of the Revit API that causes it to run a little bit slowly. Well, at any rate, this is just finishing up right now with its error message, but I'm sure everybody gets the point. Debbie P owns that stuff. We can't edit it. So it's a handy new feature available in there that then we don't have to worry about sitting through all of this. Here we go. Cannot place request until Debbie P resaves the element. So by hitting cancel, now everything in the model will revert to exactly the way it was before we even did this import at all. And so instead of wasting the time, we could have known right out of the gate, hey, go take a look in there and make sure we free up those work sets. So that's the big overview for all the new Revit features, and it's a lot to digest, but the biggest thing that I recommend always with using the RISA-Revit link is to get in and play around with the link some, because I think when you actually get in and use it, even just practicing on something, a lot of your answers will come about naturally very quickly from working with it, and it's definitely not the sort of thing where you want to, having never touched the link before, dive right into a time-sensitive project and try to get it done, because you may run into issues. But what you've seen here is that we've added a lot of capabilities in the link to make things a lot less of a struggle, I guess you would say, to go back and forth between the programs. And it's actually pretty natural and pretty easy to do round-tripping with the link. Now, we're going to continue working on this link, even though the Revit 2015 link was just released. Our plan is to work on an update to that, and so we're already hard at work on enhancements, and you can expect to see those come out in the form of a Revit 2015 V2 link at some point, and of course we're going to continue on down the line. And with that, I'd like to hand it back over to Debbie. Thank you all for attending today.